Hi, and welcome to my YouTube channel. My name is Michael. I like to pull things apart and put them back together. And sometimes I don't even get that far. I just pull them apart. Today I'm going to be pulling apart the control panel, the instrument panel actually, from a Dodge Sprinter or a Mercedes Sprinter. This instrument panel I'm going to be installing in my mid-80s Mercedes G-Class. The old G-Class uses a very low-tech instrument system. So the actual instruments are all mechanically driven, or with the meters, they're just direct meter connection to voltages, and away you go. Problem with it on my particular case is you can't see half the meters. They're all faded. They rattle. They make a lot of noise. There's a lot of work that I need to do to make them up to spec, and I don't really feel like doing it. I just want to replace it with something that's a bit more modern, a bit easier to read, a bit easier to use, and plus while I'm at it I can add some functions using microcontrollers and do some neat stuff with it. So the first step in the project is really to figure out how the Sprinter panel works, and then try to figure out what parts I need in order to build this thing. So today what I'm going to do is I'm going to pull apart the panel, take a look, try to make an estimate of how much effort it's going to take me to actually build this, and if it's even feasible. So thanks for joining, and hope you enjoy the video. Okay, so here's the panel in question. You can see it's a pretty basic panel. It's got rev meter on the left there. It's in kilometers. It's got a little mile scale for people who swing that way. It's got a temperature gauge, and it has a fuel gauge, and the pointer's missing from the fuel gauge. And I'll tell you a big secret. I've already pulled this thing apart, and because I pulled apart one of the motors in there, there is no fuel pointer at the moment. But I'll show you that when I get further. There's a couple of buttons at the bottom. Those should be useful for doing some functions. I can reprogram what those are if I put a microcontroller in. It's got a nice little display. The display itself, LCD displays, you can drive them with a microcontroller. It isn't easy. I've done it before. I'm not sure if I've got the patience to wire this one up. If you look in the pictures of these panels, they've really only got a set of numbers here, a gear indicator here, and another set of numbers on the side. Is it worth it, or should I just replace it with some sort of other panel? I don't know. Got to find something that would be good fit for it. We'll see, but I'll take a look and see how much complexity is involved, and we'll make a decision from there. This particular panel doesn't have a casing around it, so it's just a raw panel. The casing for the G-Class is ridiculously expensive. Unfortunately, with this project, I'm pretty much stuck. I'm going to end up buying that stupid casing. It comes with another panel. Yay, I don't need that. Well, whatever. Life's like that sometimes, and you gotta suck it up, and especially if you suffer from an addiction as strong as G-Class ownership. So let's pull this thing apart. Let's see what we got here. Here's a rear view of the panel. You can see there's some clips here that are used to secure the two pieces of the panel together. There's a couple of connectors at the back here. We've got this one here, another one here. There's literally dozens of pins on those. I've looked online for a wiring diagram, couldn't find anything, so I'm just going to ignore them. I don't want to use some custom pin or whatever, try to find the parts from a Sprinter wrecker or something like that. I'll just put a nice DB9 or something, cut in a hole in the back. So how do we get this thing apart? First we pop these clips, and then we see what happens. Let me just adjust the camera here. Not something you can do with one hand. Okay, so let's pop these out here. These, there, a little bit of work. A little bit of force. I'm not sure if I like these or don't like these. Kind of, if there was screws here, it'd be easier, but I guess they don't want you to pull these apart, do they? Okay, pop this here, get this side apart. And here, there we go. Okay, so the back's off. See that? Looks good. Nothing too exciting there. Thin plastic I can easily cut through and mount some custom connectors and voltage inputs and whatnot in there. And I've got my panel itself, so let's take a bit of a look at what we got here. So panel's got two connectors, one here, one there. I can probably trace these with a meter, figure out what's involved. The circuitry itself is quite fine. Everything's surface mount. You see that. So it's you know, not super user friendly. We've got some resistors here. Those are pretty big resistors for what we're dealing with. These guys here are logic chips. So it looks like these logic chips here, the pins from these actually go to the resistors, sorry, the power's coming from the resistor through here, through the logic chip, and those actually light up the lights on the other side. So we got one here, one there, little resistor pack, some transistors it looks like here, not sure what they do. These pins here, dozens of them, are for the LCD panel. Some general components here. Not sure what this is. I'm not bright enough to know just off by hand. Just looking at something what something is, but I'm gonna guess this is the power supply section. There's a few capacitors in there that would probably clean up some noise. Could be something else. I could be wrong. Looks like we've got a buzzer of some sort here. Pretty straightforward. This chip here is probably the brains of the whole panel. Now the panel's a lot smarter than just a set of instruments. The panel, you know, is going to have memory in it. It's going to probably have some security functions, CAN bus in there, so that, you know, it can communicate with the networking protocol used in the vehicle itself. All that stuff is really exciting, but it's junk as far as I'm concerned, because I'm going to rip it all out. Crystal here. This crystal, it's a bit hard to see. It can't focus at this distance, but crystal's an 8 megahertz crystal, so we got a little 8 megahertz computer basically running here, which is kind of cool when you think about it. You can see all these resistors here. Those are all tied into LEDs to light up the functions. So if I hijack these, I can just pop in some power and start lighting those things up, and away it goes. I've got some connectors here. These are the backs of the motors that are used to actually move the needles, and they just pop out. So let's disassemble this a bit further, see what we get on the other side. Okay, so let's pop this apart. It just comes out of the holding, the casing there, and we've got our instruments. So you can see here, pretty delicate looking thing. To pop the needles off, if you pull on them, you're not going to get anywhere. Pulling on these needles isn't going to get you anywhere at all. So you need to basically give them a bit of a twist and then pull them off. That's how you get them out. All friction fit. There comes another one. And let's pull this last one here. There we go. A little scary. Some switch contacts at the bottom. There's some rubber switches actually built into the housing there, so they just go in there. And now we're getting there. We're almost through onto the meat of the circuit board. Let's pop these tabs here. Everything's basically just tabs. Pop them, pop them, pop, pop, pop. There we go. Okay. Pull on this, and now we've freed the circuit board from the casing there. So if you look on this side, we've got multiple motors, and these motors are air core motors. And what they use is they use two coils, and you basically put a varying signal. I believe it's an out of phase signal, and by varying the voltage between the two, so the ratio between the two, that's actually how those motors are controlled. So they're not like a servo motor where you've got a feedback loop and potentiometer telling you where the position of the pointer dial is. These just use raw voltages in order to control it, and as long as you know the formulas, away you go. You can accurately determine where those things will end up, and that's really used in basically all modern cars. Here you can see there's a bunch of LEDs, so these are all the indicator lights. My panel, nothing too exciting. The motors themselves, you can see there's some pads here. So there's 1, 2, 3, and then there's another one right there. These are my sine and cosine inputs for those motors, and that's what I vary. And what I'm going to actually do is I'm going to use an Arduino and pop some voltages on those. I'll probably just solder right on there and control those directly. The lights themselves, the LEDs, they're all super bright LEDs, so I'll probably just leave those as is and power them somehow. It might look like a bit of a mess, but hey, whatever. Then if I take the panel part apart here, so here's the panel itself, and you can see there's little slots in there for each of the individual lights. So an LED is in each of these little pockets. It lights up when something's going horribly wrong, and you're alerted to it. There's also what's really cool about this panel, and what unfortunately is a cool feature I don't want to get rid of when I build my own version, is that these actual motors, there's a LED under the motor. The shaft of the motor is clear, so what happens is that causes your little display panel to light up, your little pointer to light up, which is I think is a nice feature. And well, if you saw my display, my instrument panel today, you'd think it's a nice feature too, because I don't have any lights. So I'm going to quickly show you the motors themselves and kind of a little bit of how they work. This is the disassembled motor. So in the motor itself, I'm missing a piece here, there's a little gear. In the motor itself there are 2 coils, and basically you adjust the current, the power going through each of these 2 coils. That causes this little gear here, sorry the focus is a bit out, this gear here to turn, which then in turn moves the needle gear, and your pointer is plugged basically right on there, and away you go. This is something a lot of people have done it before, easy to control with an Arduino. It's mostly just soldering. It's not a lot of experimentation or new science I'm doing in order to make this work. So it should be pretty straightforward. What it doesn't look like is I'm going to be able to reuse these connectors. They're just too complicated, these connectors here, big mess. I don't want to deal with that. So I'll probably just bastardize things, drill a bunch of holes in this $100 panel. I probably paid about 150. I actually paid 100 euros for this thing. So this $150 panel I'll just make a mess of and use it more as the platform for holding all the circuitry. Pop maybe a circuit board back here, a little experimenter board. Pop an Arduino in. Use a couple of DB9s or something, decent connectors to run the signals, and away you go. So it looks like this project's going to work. Just going to be a bit of effort and a bit of time, and should be fun.